So welcome everyone to the live session. This is the first live session, and in these sessions we will be discussing the assignments. We will be solving those assignments and discussing in this class. And these assignments will be from the basic thermodynamic course that is offered by IIT Guwahati in collaboration with NPTEL. And I am Akhilesh Goyal, a PMRF scholar from IIT Bombay, and I will be taking these lessons throughout the course. So to start with, let's go to the first question. So the first question is which one of the following represents open thermodynamic system? So to go to those options, before going to those options, let us first understand what is a thermodynamic system. So a thermodynamic system is basically a quantity of matter or a region in the space upon which we are putting our attention to solve a particular problem. Apart from that quantity of matter or like that region, everything is surrounding, and the thin layer that separates the system and boundary, that system and surrounding, that is called as boundary. And now what is an open thermodynamic system? So thermodynamic systems are three type. The first one is open system. So a system, if in a system, if the heat can be transferred, and also the interaction of mass is also possible in that system is called as open system. But if the mass transfer is not possible and only heat transfer is possible, that system is called as closed system. Here you can see that. And if the transfer or interaction of mass and also the heat both is not possible, then it is called as isolated system. So now let's go to the options. So the first option is manual ice cream freezer. So as we all know, in the manual ice cream freezer, the ice is packed into a box, and then the liquid is put into that box to freeze it. So we can see that in manual ice cream freezer there is a heat transfer, but no mass transfer is possible because the that ice that is packed inside the box is there only, and it is not the mass is not being transferred into that. So that is a closed system. Okay. The second option is centrifugal pump. So as in the diagram you can see that the water or fluid comes through the center of the pump and then goes out from the periphery of the pump. So here we can see that the mass transfer can be seen into this mass interaction can be seen into the centrifugal pump, and also from this rod the work is also transferred to the impeller. So we can say that mass as well as heat transfer uh, is present in the centrifugal pump. So centrifugal pump is a open thermodynamic system. Also the next option is a pressure cooker. Again, in the pressure cooker the mass is constant, no mass transfer is possible there, but the heat is being transferred into that. So that also comes into the closed thermodynamics closed system category. Okay. Now last option is bomb calorimeter. So what is a bomb calorimeter? So here in the figure you can see a schematic diagram of bomb calorimeter. So bomb calorimeter is a device that is used to measure the calorific value of the fuel or any fluid that can burn itself. So here you can see the walls are adiabatic walls, so heat transfer is not possible there, and also mass transfer is not there. So here you can see neither mass nor heat is being transferred into the system. So this bomb calorimeter is an example of isolated system. Okay, so from all four options, the one centrifugal pump is a open thermodynamic system. Okay, so any doubt till here? Okay, so if you don't have any doubt till here, we can move to the next question. So the next question is the cyclic integral of dq minus dw for a process is what? Okay, so here dq is the heat transfer, the amount of heat transfer, and dw is the amount of work transfer. Okay, and uh, it is the question is asked for cyclic integral. Okay, so see, for cyclic process, uh, uh, yeah, so one minute, yeah, so for first law of thermodynamics, according to first law of thermodynamics, uh, the difference between the heat transfer and the work transfer is the change in entropy. So the amount of heat transferred to the system and the amount of work transferred from the system or work done from the system, the difference between these two quantities is known as the change in energy of the system. Okay, so it is the energy that stores into the system. Okay, so if so yeah, so this this equation is for any process, but if we are considering a cyclic system, so we can see that that the process starts from a point and comes back to the same point. So it, like from the, you can see the point A. So a process start from point A and then going through multiple processes came to the same point A. So here, if we do the integral of this equation for a cyclic process, so here we can see the cyclic integral of dq minus del w, that is equal to cyclic integral of del E. But we know that energy is a property, and property is a point function, not a path function. So as in the cyclic process, the cycle starts from a single point and comes back to the single point. So here the change in energy is 0. So we can say that for a cyclic process, the cyclic integral of del q minus del w is equal to 0. So the option B is correct here. Okay, so yeah, this is the answer. So any doubt in question 2?
No doubt.
Okay, so let's move to the next question. So the next question is uh, the property of a thermodynamic system is a path function. Yeah. So it is a true false question. So the property of a thermodynamic system is a path function, whether it is path function or not. So what is a thermodynamic property? So thermodynamic properties are used to describe the state of a system. So how you can describe the state of a system? Like what is the pressure, what is the temperature, and what is the volume of that particular point, and what is the energy, and those all those parameters, all those characteristics are called as properties. So for a given state, these properties have a definite value, and if a state is changing, we can say that the property is also changing, and these properties are point function. So if you go from, yeah, here you can see, if you go from point A to point B through different routes A, B or C, but you are reaching at the same point, and these properties describe a state of that point, not that what path it has followed through to come from point A to point 1 to 2. Okay, so here these properties are path function. So here, so sorry, so these properties are point function, and the question asks us like properties are property is a path function, so it is false. So a thermodynamic property is a point function, and for a cyclic process, uh, the change in property is zero. Okay. Now move to the next question. Here, identify the extensive properties. So before going to this question, we need to know how many type of these properties are, and what is extensive property and what is intensive property. So thermodynamic properties are of two types. The one is intensive property and the second is extensive. Intensive properties are independent of mass, and extensive property depend on the quantity of mass. Okay, so one is mass independent property and the second is mass dependent property. So what properties depend on mass, what does not depend? So for that, here is a simple diagram. So consider uh, in a single volume, here we have uh, mass m, volume v, temperature T, and the density and pressure are rho and P. So in a simple experiment, if we divide this whole volume into half, we can see that volume divided into half, the mass also becomes half, but the temperature remains same, the pressure remains same, and also the density remains same. So we can see, as we divide this whole volume, two properties are also becoming half. So these two properties, mass and volume, these depend on the amount of mass. So these are called as extensive properties, but the temperature, pressure, and density, these property doesn't change with the mass. So these are intensive properties. Okay, now we go to the options. So again, temperature, we know temperature doesn't change with the mass, so it is not an extensive property. Viscosity also doesn't change with the mass, but internal energy, it changes with the mass, more internal energy. So this is the extensive property. And also the entropy is also extensive property, because more mass, more disorderness, and more entropy. So this is also a extensive property. So option C and D are correct. Also uh, also specific extensive properties. So what is an specific extensive property? It is extensive property per unit mass. So again, in specific extensive property, you are dividing the properties by mass. So these property doesn't depend on mass. So specific extensive properties are intensive properties, because they doesn't change with the mass. We are already dividing these properties with the mass. So these comes under category of intensive properties. Okay. So any doubt till here? Okay, let's move to the next question. So next question is a small numerical. So a Carnot engine rejects 50% of heat absorbed from a source to a sink at 27 degrees Celsius. what is the source temperature. So first we see how a Carnot engine looks in a schematic diagram. So here you can see uh, heat Q1 is taken from the hot source, that is at temperature T1. A small amount of this heat Q1 is converted into work W, and the remaining heat is transferred to the cold sink, that is at temperature T2. Okay, so this is how a schematic of Carnot engine looks like. So yeah, so in the question what is given, the engine rejects 50% of heat absorbed from the source. So here the heat rejected is Q2, and that is equal to 0.5 of Q1, as 50% of heat is uh, being rejected. Okay, and yeah, and in the efficiency equation we can see the efficiency of the uh, this Carnot engine is 1 minus Q2 by Q1, and in terms of temperature it is 1 minus T2 by T1. So by putting these values here, 1 minus what is Q2? Q2 is 0.5 Q1 by Q1 is equal to 1 minus what is T2. So here the temperature of sink is given as 27 degrees. So that is 273 plus 27, that is in Kelvin, divided by T1. Okay, so this is 1 minus 0.5 is equal to 1 minus 300 by T1. So 0.5 is equal to 1 minus 300 by T1. So 300 by T1 is equal to 0.5. Solving it, T1 is equal to 600 Kelvin. Okay, so 600 Kelvin is equal to 273 plus 327. So 327 degree centigrade, that is the temperature of source. So we see in the question, so what is asked is what is the source temperature. So the source temperature is 327 degree centigrade. Okay, so this Carnot engine is taking heat from the source at temperature 327 degree centigrade and rejecting the 50% of heat to the sink at 27 degree centigrade. Okay, now let's move to the next question. So the next question is, a reversible heat engine rejects 80% of the heat supplied during a cyclic operation. If the engine is reversed and operates as a refrigerator, then its coefficient of performance shall be what? Okay, so this question is for reversible heat engine. So again, let's see the schematic diagram. Okay, so here it is saying the engine rejects 80% of the heat. So heat rejected is Q2, that is 0.8 of Q1, the 80% of Q1. Okay, and now this this engine is working as a refrigerator, and we have to find out the coefficient of performance. So here you can see the coefficient of performance is defined as uh, the Q divided by W, and this Q cold is the heat that is taken from the cold environment. Okay, so here you can see the cold environment, or the cold sink is at the lower temperature, where from the heat is being uh, taken and it is rejected to the hot source. That's how a refrigerator works. Okay, so to calculate the coefficient of performance, so COP is equal to Q cold divided by W, and Q cold is Q2 and W is Q hot minus Q cold. So Q hot is Q1 and Q cold is Q2. Okay, now putting the value of Q2 here, so Q2 is 0.8 Q1 divided by Q1 minus Q2 is 0.8 Q1. So this comes as 0.8 Q1 divided by Q1 minus 0.2, 0.8 Q1, 0.2 Q1. So solving it, 1 upon 0.2, that is 4. Okay, so COP is 4. So that is our answer. So for the given system where uh, the reversible heat engine that rejects 80% of the heats, if we reverse it and use as a refrigerator, then the COP, the coefficient of performance of this system, will be 4. So that is the answer. Okay, so any doubts, any problem till here? Okay, so let's move to the next question. Yeah, so the next question is, for a real thermodynamic cycle, which one of the following is correct? Okay, so the cycle integral of del q by t, so what should be the value of that for a real thermodynamic cycle? So here, by real means, irreversible thermodynamic cycle. Okay, so yeah, so the inequality of clauses tells us, like, for any process AB, del q by del t is always less than or equal to del s, where s is entropy. Okay, then this is defined for a process AB. Then for a cycle, the cyclic integral of both the sides. Okay, but as we know, the s, that entropy is a property, then the cyclic integral of a property is always 0. So we can say for a cyclic integral uh, of del q by del t is always less than or equal to 0. Okay, now there are three conditions that are possible. The first is the cyclic integral of del q by t is 0. That is only possible for reversible cycle. Okay, and the second possibility is del q by t is less than 0. That is applicable for irreversible cycles. And the third condition, that is del q by del t, the cyclic integral of del q by del t is greater than 0. So that is not possible because it violates the second law. So here in the question, uh, the condition is the real thermodynamic cycle, and real thermodynamic cycles are irreversible cycles. So from the second condition here, the cyclic integral of real thermodynamic cycle should be less than 0. So the option B is correct. Okay. Yeah. So now let's move to the next question. Yeah. So there is no work transfer involved in this process. So the four options are given, and it is asked like which process there is no work transfer. Okay. So let's see for adiabatic expansion. For adiabatic expansion, so see this graph. So this graph is PV graph, pressure versus volume graph, and they, the work dW is defined as P PdV. Okay, and yeah, okay. So the work done is defined as PdV, and here in the graph you can see the multiple processes. So yeah, so first consider the adiabatic expansion. So adiabatic expansion follows PV की power gamma is equal to constant. Okay. So here in this plot you can see PV raised to power n is equal to constant, where the value of n varies from 0 to infinity. So and the value of gamma ranges from 1.3 to 1.67. So in the graph you can see it must come here between 1 and 2, and the work done is defined here as the area under the curve. Okay, so that is PdV. So and also from the equations, uh, this from the polytropic expansion, that follows as PV raised to power n is equal to constant. uh, so for adiabatic expansion or polytropic expansion, where the value of n can be gamma and any other value from 1 to multiple values like 1 2 3 or anything, this can be the value. So here for polytropic expansion and adiabatic expansion, there is always some work, always some area under the curve. So for both the processes, adiabatic and polytropic, the work done is not zero. It is something non-zero value. And also for isothermal expansion, uh, that follows PV is equal to constant. So the value of n is equal to 1 for PV is equal to constant. So here also you can see there is some work, there is some area under the curve. So also for isothermal expansion, the work done is not zero, work transfer is not zero. In fact, for isothermal expansion, the work done is maximum. Here you can see in the graph. Okay, and if we consider the final option, free expansion. So in free expansion, what happens is, uh, yeah, so in free expansion, there is no resistance to volume change, or the expansion happens without any resistance, and work is always done to overcome that resistance. But as the resistance is not present there is no work involved, and work transfer is zero. So here in this question, out of these four expansions, only the uh, free expansion is there, where the work done is zero or work transfer is zero. So the option D is the correct option. So out of these four type of expansion, in free expansion there is no work transfer. Now let's move to the next question. Yeah. So the next question is, A closed gaseous system undergoes a reversible constant pressure process at 2 bar in which 100 kilojoule of heat is rejected and the volume changes from 0.2 meter cube to 0.1 meter cube. Use the given data to answer the following question. So the first question is, what is the work done by the system? Okay. So let's first draw a rough sketch. So it is a PV diagram. So the process is constant pressure process. So let's see. This is P is equal to 2 bar. That is constant pressure, and volume. The initial volume is 0.2. So let's see. The initial point is this. The point 1 is here at 0.2 meter cube volume and 2 bar, and the process is constant pressure process, and volume changes from 0.2 to 0.1 meter cube. So this process goes in this direction. Okay, so consider this is point 2 and the volume is 0.1 meter cube. Okay, now in the question 1, what we need to find out is what is the work done by the system. So the work done by the system is area under the curve, that is W. Also W is integral of P dV. Here P is constant and volume changes from point 1 to point 2. So V2 minus V1. This is the volume change. So here putting the value. So pressure is at 2 bars. So 2 into 10 raised to power 5. That is in Pascal. And volume changes from point 2 to point 1. So V2 is point 1 minus 0.2. So the W total work done is 2 into 10 raised to power 5, 0.1 minus 0.2. So 2 into 10 raised to 5 into 0.1. So that is 20 into 10 raised to power 3 joule or 20 kilojoule. This is minus. Okay, 1 minute. So it is 2 into 10 raised to power 5 into minus of 0.1. So it is minus 20 into 10 raised to power 3 joule. It is minus 20 kilojoule. Okay. So
आई थिंक W W 10 to देर 4 होना चाहिए ना. Sorry,
W
take
is
it.
what? Please. Any doubt? So here the pressure is given as 2 bar and the bar is 1 bar is equal to 10 raised to power 5 Pascal. Okay, in SI units. So we put this value for the pressure. So solving it, W comes as minus 20 kilojoule. So what it means by minus 20 kilojoule? It means the work is done on the system. That's why so when the work is done on the system, the work is negative in that case, and when work is done by the system, then work is considered as positive work. Okay, so here the work is being done on the system. So 20 20 kilojoule of work is done on the system, and also here see 100 kilojoule of heat is rejected. Okay, so come to the next question. Here let's assume this is our system. Okay, and heat Q is equal to 100 kilojoule is rejected, and work W is equal to 20 kilojoule is done on the system. Okay, so uh, the change in internal energy of the system. So what is the change in internal energy of the system? So what is the internal energy? Internal energy del E is Q minus W. Okay, so here Q is 100 kilojoule that is being rejected from the system. So here Q is minus 100 kilojoule, and W is 20 kilojoule, that is the work done on the system. So here W is also minus 20 kilojoule. So putting these values, minus 100 minus of 20 kilojoule, so it comes as minus 100 plus 20 kilojoule, that is minus 80 kilojoule. So the internal energy change is minus 80 kilojoule. That means the internal energy of the system is decreasing as the system has transferred 100 kilojoule of energy to the surroundings, that is given in the question. So this is the change in internal energy of the system. So that is, yeah, so Q is del E is minus 80 kilojoule. So any doubts till here? Because this was the last question of the first assignment. Sorry, assignment 0. That is a prerequisite assignment. So, do you have any doubt till here? Okay. So, so that's all for the today's session, and I encourage you uh, to watch the lecture videos before coming to the next session, and also to try the next assignment before coming here, so that you can have your doubts solved here, uh, and also please keep joining this session. These will help you, and yeah, that's all for the today's session. Okay, if you don't have any doubt, I'm closing the meeting, and see you all in the next session, the session 1, that will start from the next week. Okay.